Good morning. Today we are going to be talking about ratios, which connect amounts. So, like for you guys, a common example is if you've got sort of a bag of fertilizer, maybe that is providing boron um, to the soil. Let's say that fertilizer might be 20% boron. Now that 20% is a ratio, and it's commonly written as 20 over 100. So in this case, like if it was a 100-pound bag of fertilizer, well, 20 of those pounds would be boron. Now, we can use ratios in equations to help us connect other ideas, like say how much fertilizer we want to actually add to a field of a given size. Anytime we've got two ratios equal to each other, like for instance, 1/2 equals 3/6, we call this thing a proportion. Now, there are other definitions of proportion. Really, we could talk about proportions anytime two things are related by multiplication or division. Um, but anytime you see two fractions and an equal sign, you are dealing with a proportion. And there's a bunch of patterns here that we should be aware of. So first of all, if you go across the proportion, you might notice a pattern here, and that I am multiplying by the same number. 1 times 3 gets us 3, and 2 times 3 gets us 6. There's another pattern if I go down the proportion on their own side. Notice that 1 is half of 2, or I would multiply 1 by 2. And the same thing is true over here. 3 times 2 would get me 6. Now finally, and this is actually the most useful of the patterns, and it's not super obvious at first, but if you go diagonal across the proportion and we multiply the diagonal numbers, 1 times 6 and 2 times 3. Well, it turns out that those diagonal products, will always be equal in a proportion. In this case, 1 times 6 is 6, and 2 times 3 is also 6. And this will be true for any proportion, and so we can actually use this really to our advantage. So in the example, 10 over 60 equals x over 12. There's a few different ways of going about this. You might look at this and go, well, 10 times 6 is 60. So maybe I could think of a number that I could multiply by 6 to get to 12. Or you could think, oh, 12 times 5 is 60. So maybe there's a number I could multiply by 5 to get 10. But the sort of foolproof way, what we'd call like an algorithm, that's always going to get you your correct answer, is multiplying our diagonals and setting them equal to each other. 60 times x, we write as 60x, and that must be equal to 10 times 12, which is 120. To solve that equation, we just divide both sides by 60, giving us x on that side, on the left side, and 120 divided by 60 is 2, which you may have already been able to see just looking at the pattern. The nice thing about this cross multiplication method is that it works for us even when our numbers are a lot grosser and we can't see a pattern at first glance. For instance, what if I gave you the proportion 11 over 100 equals 4.2 over x? Well, it's not super obvious what I'm going to multiply 11 by to get 100. And same thing with like 4.2 and 11. So the pattern idea doesn't work so great here. But if we cross multiply, 100 times 4.2 is 420, and 11 times x is 11x. And to solve that equation, we just divide both sides by 11. Pretty predictable algebra here. It follows a pattern. And x equals, in this case, it is a decimal, but cross multiplication worked just fine here. So in your fertilizer math, some of these soil amendment stuff, you are going to be having to set up proportions like these yourself and solve them. And oftentimes the numbers are going to be not super nice. They're going to involve decimals, and so we're going to probably rely on this cross multiplication method when we're doing all our math.